Okay, so what I'm going to go over right now is how to find the length of your first jack stud. So if we come back here to this drawing here, the length of this jack here, which is the light blue. So there's our jack. So we need to find the length of this first, the longest one, to the short point, not the long point. And then we need to find what is the length difference between the first one, the second one, and the third one. And every one after the first one will be the same. So if you were doing 10 after the first, all the 9, there would be an equal distance between the length of those. So the length between the first to the second, if it's 9 inches, that would be the same as the difference between the second and the third, which would be 9 inches, to keep an equal on center distance, such as we have here, which is, as we were seeing, 8 inches on center. So that's what we're going over. Let me show you what the processes are. There's 3 processes, each with their own steps. So the first process is going to be find the total rafter run of the short point of our jack. So just like we find the total rafter run of a common or of a hip, we need to do that to the jack stud, but to the shortest point of that. So when I say the shortest point, what that means is, again, coming down here, that's this point when it's cut on a 45, is this point. So that's step number, or process number 1. Process number 2 is find the line length of the jack rafter. So we're going to take the unit line length and we are going to multiply that by the total rafter run, and then we will find the total length. Then the third process is to find the difference of the length between the first jack rafter and all the subsequent ones going from there that are getting smaller. So let's start with process number 1. The first one process is to find the total rafter run by taking our span minus our ridge thickness and dividing that by 2. So if we come back here to our illustration, our total span is 6 feet, because we've already found that this distance to the center of the ridge was 3 feet. So what we need to do is, we found that we need to subtract the thickness of our ridge, which this is our ridge. So our ridge is 1.5 inches. So we are going to subtract, well, let's just say our span is 6 feet. So we need to go 6 feet minus 1.5 inches, which gives us 5 feet, 10.5 inches. And we're going to divide this by 2, which is, you could also just subtract 3/4, which is half the thickness of the ridge, and we already have the run of the whole building. So that gives us 2 feet, 11.25 of an inch. So let's take that number and write it here. 2 feet, 11.25 inch. So that's step number 1, which we've done that before. Step number 2 is we need to find the hip reduction by the hip width divided by 2. Normally our hip width is 1.5 inches, equals A. A is the same as B, so if A was 2, B would also be 2. And then we are going to solve for C using the Pythagorean theorem, which is A squared. So if it was 2, we would say 4. A is the same as B, so it would be 4 plus 4 equals c squared. So then we'd have to find the square root of c on our calculator. So let's go over to our diagram here. So what we are trying to do is, we just found on step 1 was we just found this distance. So we moved it from the center of our ridge to the outside of our building to the inside of our ridge to the outside of our building, which we said was this dimension here. Now what we're needing to do is we are needing to find what this distance is right here. So this hip, this is our hip. On this diagonal, so remember here's our triangle, we found what A and B is right here, which was our distance, our hip thickness. Our hip thickness was 1.5 inches. So A is 3/4 because that's half of 1 1/4. So let's take it up to our bigger portion. We're trying to find this distance right here. So our triangle is right here. So if our distance, if the thickness of our hip is 1.5 inches, half of that is 3/4. So 3/4 of an inch here, 3/4 of an inch here, and we need to find what this measurement is so that we can figure out what this length is to the inside of our hip. So what we're going to do is come back over here, and we're going to use the Pythagorean theorem. And we're going to go over to our calculator. We have to close our advertisement. So we're going to say 0.75 squared, so that's A squared, plus B squared, so we're going to go plus, B is equal to A, so another 0.75 squared, and that equals 1.125. Now that's equal C squared, but if you remember, we need to find the square root of C because we don't want C squared, we just want C by itself. So we're going to come here, and we're simply going to press the square root button, which is this one right there that you see me pressing. We're going to find the square root of that, and we get 1.06066, which we're just going to call as 1. So C equals, over here, C equals 1. So now we have the answer for step number 2. Now it says add the distance of the jack rafter on center space to the number found on step number 2. So step number 2 we got 1. So what we're looking at for this step number 3 is what is the on, these jack rafters are spaced 8 inches on center. So from center of this common to center of this jack is going to be 8 inches, just like the center of this jack. The center of this jack is going to be a span or an on-center distance of 8 inches. Just like in a typical wall, we go 16 on-center. We're choosing to do 8 on-center. So for step number 3, we simply just need to add 8, because that was our 8 on-center, plus 1 equals 9. So now we have the answer for step number 3. Step number 4 is simply to subtract the answer of step number 3, which is 9, from the answer of step number 1, and this gives us the total run for the longest jack rafter to the shortest point. Again, here's our shortest point. So answer number 1 was 2 feet 11 1/4 of an inch. So we're going to write that 2 feet 11 1/4 of an inch, and it said we're going to subtract 9 inches, and what that does is that gives us our answer for process number 1, 2 feet 2 1/4 of an inch. So what did we just find? we just found the distance of this point right here. So the first thing we did was we subtracted half the thickness of the ridge. Step number 2 was we subtracted this distance, so this was number 1. So it was number 2. Then we knew that we were going to drop 8 inches here. So that step number 3. So now we just did our math of subtracting that from our total run, which was 3 feet. So we added 1 plus 2 plus 3, and we got that distance, and step number 4 came up with this distance. So now we know from this point to this point is 2 feet, 2 1/4 of an inch. So that was process number 1. Now, just like we did for our commons, we have our total run from here out to here, and we just simply need to find our run, our unit total run per foot, and multiply that by this distance in decimal feet. So let's go to process number 2. So find the line length per foot for the slope pitch of your roof on the framing square. Okay, so we're going to say it's a 5 and 12. 5 and 12, which means our per foot run is 13 inches. Okay, so we just found this on our framing square. Then step number 2 is we're going to multiply that number by the total run found in process number 1 in decimals of foot. So we're going to take that number and we will multiply it. However, what we need to first do is let's write this. Oh no. So now we're going to take 13, but let's find the decimal of a foot for 2 feet, 2 1/4 of an inch. So if you remember, we're going to divide 1 divided by 4 plus 2 divided by 12 plus 2. So let's do that on our calculator. So here, 1 divided by 4 equals, plus our 2 inches equals, divide by 12, because we want to go to feet, equals, and then we're going to add our feet plus 2 equals. So 2.1875. So now we're going to take that. This equals 2.1875 of a foot. And we're going to multiply that by 13. Which, go to our calculator, equals 28.4375. Okay, of inches. So this is equal to, we multiply this by 16 to get it in a fraction of an inch, so it's actually 28 7/16 of an inch. So that's our answer. Now we know that if we went to lay out this jack rafter, we would know that this distance down to this distance equals 28 7/16 on the diagonal, right? So coming up like this. And we'd cut our little bird's mouth. Oops. Cut our little bird's mouth in there. and then we'd have our diagonal there. So now the third process is we need to find the difference of our, let me erase this, sorry I forgot to erase this. We need to find the difference of the jack rafters. So we just found the longest one, and now what we need to do is find what is the difference between the longest to the next jack rafter to the next one. And once we find that measurement, we're just simply changing that and subtracting that from each subsequent jack rafter length. So it's very basic. All we need to do is adjust, process number 3 is adjust our unit pitch to match the on-center spacing of the roof. So for example, our pitch is 5 and 12, which means our per foot run is 13. Okay, we know that. So our jack rafter on-center spacing is 8. So what we need to do is if we draw this triangle out, okay, so every 12 inches we rise 5 inches. However, we only want to go every 8 inches. So we're cutting our 13 down. So here's what we need to do. This distance we know is 13. What we want to do is divide it into 12 equal parts so that we know the distance of this, 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 and then we're changing this distance to 8 inches because we're doing 8 inches on center. So how do we do that? It's very easy. We divide the per foot run, which is 13, divide it by 12, because we're going to break it into 12 equal parts, and then we're going to multiply that number by 8, or whatever unit spacing or on-center spacing you were using. So let's go to our calculator, close our advertisement. So we said 13 divided by 12 equals, oops, not multiply. Okay, and we multiply that by 8 equals 8.6666. So now we're going to take that, which is equal to 8 5/8. So now what did that information give us? So we were able to lay out jack rafter number 1. Now we know that from the short point here down to this short point is a distance of 8 5/8. So if our first one was 2 inches, 2 1/4 to its short point, our next one is simply going to subtract 8 5/8 from this one, which if we do that, we need to borrow a foot, which gives this 12 inches. So now we have 14, but we're going to borrow one from here to give this 5/4. We're going to make this 8. 4 goes into 8 twice. 2 times 5 is 10, so 10/8. So we have 5/8. 10 minus 5 is 5. You keep the common denominator, always has to be common. Then we had 11 left over plus 2 is 13, so 13 minus 8 is 5. 5 5/8, and we brought 1 foot down. So now we know that the distance from this short point to the outside of the wall is this distance here. And then if we wanted to find the distance of this jack rafter, we would simply subtract another 8 5/8 of an inch. And that would give us this length here. So, in review, 3 processes. The first one was we needed to find what this length was here to the outside of the wall. Short point of our jack rafter, which we did in process number 1. Process number 2 was we needed to find, now that we knew this total run, we multiplied that number by our unit run, which gave us this distance here. So sorry, the first process was finding how much shorter it was. Then we found it, that was on the horizontal. Second was on the diagonal, how long that distance was. And then the third process was to figure out how much different or how much shorter all of these jack rafters would be from the first initial one. So please let me know if you have any questions. Hopefully this helps. And we'll see you in class tonight.